All right, guys, here's part 2 for integration by parts. This is using the tabular method. Pretty cool stuff. So we're still going to look at this guy, and we can see we can't integrate this. If I make 4xu, if I make 4xu, find the derivative of that, I get 4dx. I can't fudge fix. I'm stuck. Integration by parts would be obviously applicable here. You can do the way we saw in part 1, or this tabular method that I like to show you, okay? So what we're going to do is we're going to actually set up a table. Okay, this first column is going to be for your sines. Okay, your second table is going to be for u, and your third table will be for dv. Keep in mind, for u, we're still going to derive. We're going to find the derivative of this guy, and for dv, we're still going to integrate this side here. Okay, so we were still going to choose the one that comes first in our acronym for LIAT. E is exponential, A would be algebraic. Algebraic comes before the E, so we're going to make U 2x. And then we're going to make dV e to the 4x. Okay, our signs are going to always alternate. They're going to start with positive and then alternate. We're going to find the derivative of u all the way until we get to 0. So I have x squared. The derivative of x squared obviously is 2x. The derivative of 2x is 2, and the derivative of 2 is 0. And that's the outcome. That's what we're looking for. That's how we know we're going to stop. So our signs alternate from positive to negative to positive to negative. I'm going to now integrate this side. Now when I integrate this side, keep in mind I'm not finding the derivative. A lot of people want to find the derivative, but we would integrate this guy. So I would make u for x. So I would have to fudge this with a 4, fix it with a 1/4. Okay, and we would do that again and get 1/16. And we would do that again and get 1/64. Okay, now what we do is the way we set this up is this is going to be equal to, we go across and then diagonally. All right, so what that means is I have a positive x squared times 1/4 e to the 4x. I go across and then I go diagonally. So that means I have negative 2x times 1/16 e to the 4x. We're going to do it again across and diagonally. Okay, so that gives me a positive 2 times 1/64 e to the 4x. And then we're going to clean this up. So I'll write this as 1/4 x squared e to the 4x minus 1/8 this x is up here with that guy, obviously. So that would be 1/4 x e to the 4x, and then this would be 1/32 e to the 4x, and then, of course, our constant of integration. So if we were to actually do this using the traditional integration by parts, this is what we would get. Okay, let's check it out. Let's try it one more time just to get the hang of it. Okay, so again, we're going to set up our table here. I have my signs here. My algebraic x cubed over my sine. Actually, this would be our u, and this would be our dv. So I'm just going to move x cubed down here. And then our dv would be sine of 2x. All right, starts off positive, and I'm going to derive this all the way down. 3x squared, 6x, 6, 0, which means my signs are here, would alternate. if I integrate this, keep in mind I'm integrating this, right? So I'm going to make u 2x, so du would be 2dx. I would need a 2, so I would fudge it with a 1/2. All right, since I'm finding the integral of sine, it would be negative cosine, so it's negative 1/2 cosine of 2x, and we would do that again, and we would get negative 1/4 sine of 2x. Do that again, we would get 1/8 cosine of 2x, and if we do that again, we would get 1/16 sine of 2x. So now we're going to put this together. Okay, we'll come across and diagonally. So that gives us negative 1/2 x cubed cosine of 2x. The minus and the negative would make it a positive 3/4 x squared sine of 2x, and I'm just going to come and continue to write it down here. So then I've got 6/8, which is another 3/4 x cosine 2x. Come across and down one last time. 6/16 is going to be, sorry, that would be a minus 3/8 sine of 2x plus c. That's a minus there. Okay, so that would be the tabular method. Okay, now couple points. Okay, it has its limitations. All right, before people get excited and go, this is awesome, I love patterns, patterns are totally mathematical, you know, this looks cool, I'll just use this, okay? Well, it has its limitations. It doesn't work on all functions. Okay? Now, keep in mind, the key here is that when we find the derivative of u, it's got to go to 0. So it was effective. Can you guys think of any type of functions where if you go to find the derivative of it, it won't go to 0? And I'm sure you're thinking with sine of x or cosine of x, okay? Because it'll never go to 0. Never go to 0, okay? It's we know those as being periodic functions, so they repeat, and there's a cycle there. All right, so it has its limitations. It's definitely worth noted. And last but not least, make sure, and this is important, folks, okay, make sure you check all other types of integration before you try to use parts. Okay? Super important there. All right, well, I'm going to head out here. It's good stuff. That's it for the year, folks. Great job. You guys did it. You made it through a year AP Calc. I hope you guys enjoyed it. I love it. I think you guys can tell. But, you know, in spite of everything that's happening, you guys did fantastic. July 15th, they're going to be posting the results, so make sure you guys tune in. I'll surely be checking as well, and I'm sure everybody did fine. Look, I think we were like super over-prepared with everything that happened. It's better to be over-prepared than under-prepared, of course. So I will see you guys. Some of you guys I'll see next year. To my graduates, have a great summer, healthy summer, super college experience. You guys are going to do very well. Congratulations. You deserve it. I know it's not the way you wanted to go out, but I'm very proud of you. And best of luck, and keep in touch. See you guys.